Welcome to 2026. The AI infrastructure landscape has settled on a champion, vLLM. Serving billions of tokens weekly for giants like Roblox and Meta, this engine has evolved into the definitive standard for open-source inference. Today, we're diving deep into the vLLM v1 architecture and the groundbreaking Model Runner v2 that's redefining what high-performance serving actually looks like in production environments. The numbers don't lie. With the March 2026 release, we're seeing 56% higher throughput on NVIDIA GB200 Blackwell hardware. By moving the scheduling logic and input preparation onto the GPU, utilization now sits between 85 and 92% under heavy load. This isn't just a marginal gain, it's a fundamental shift in how we handle the physics of attention and the KV cache. LLM Inference has a physics problem. Attention is quadratic, and traditional batching fails when requests have different lengths. vLLM's paged attention solves this by borrowing from operating system logic. It divides the KV cache into fixed-size pages, mapping them on demand. This eliminates fragmentation, dropping it from 80% to under 4%, allowing you to pack more users onto every single GPU. The v.17.1 release introduced Model Runner v2, a complete rewrite of the execution core. It's built on three pillars: modularity, GPU-native kernels, and async-first execution. By using Triton kernels for input preparation and sampling, vLLM has finally removed the CPU from the hot path, ensuring that your expensive GPU hardware never has to wait for a slow host processor to make a decision. Getting started is a single command. This Docker setup mounts your Hugging Face cache and exposes the OpenAI-compatible API. Note the GPU-memory-utilization flag set to 0.90. This ensures vLLM reserves enough memory for the KV cache while leaving headroom for the model weights. It is the fastest way to turn a raw NVIDIA box into a high-performance inference server for Llama 3.1. For production scale, you need Kubernetes. This deployment manifest defines a vLLM server with Prometheus monitoring enabled. We specify GPU limits and set the tensor parallel size to match our hardware. The readiness probe is critical here, ensuring the load balancer only sends traffic once the massive weights are fully loaded into GPU memory and the engine is primed for the first request. Once your container is running, interacting with it is seamless. Because vLLM implements the OpenAI API protocol, you can use standard curl commands or any existing SDK. Here we see a prompt being sent to Llama 3.1 8B. The response includes the generated text and usage statistics, allowing you to monitor token throughput and latency in real time, right from your terminal. The v1 architecture is a masterpiece of distributed systems. It splits the workload into isolated layers, communicating via 0MQ. The API server handles requests, the scheduler manages the queue, and the workers execute on the GPU. This separation means scheduling decisions happen without touching the GPU, eliminating the CPU-GPU round-trip bottlenecks that plagued earlier versions of the inference engine. Three specific changes define the Model Runner v2 era. First, GPU-native input preparation using Triton kernels. Second, async-first execution, where the scheduler prepares the next step while the GPU is still processing the current one. Finally, a Triton-native sampler that eliminates the need for PyTorch-level synchronization. Together, these features ensure that the execution pipeline remains fluid and high throughput. Scaling to 70B or 400B models requires more than one card. vLLM handles this through tensor parallelism. By setting the tensor parallel size flag, the engine automatically shards the model across multiple GPUs using NCCL for high-speed communication. This allows you to serve the largest models with low latency, maintaining the same OpenAI-compatible interface regardless of the hardware complexity. In 2026, vLLM isn't just an option, it's the foundation of the OpenAI stack. Its ability to squeeze every drop of performance out of modern silicon while maintaining a developer-friendly API makes it the undisputed king of inference. If you are serious about deploying LLMs at scale without the cloud provider lock-in, vLLM is your path forward. It is the bridge between research and reality. Ready to build your own AI infrastructure? The full technical breakdown, including benchmark comparisons against SGLang and TGI, is available now. Stay ahead of the curve in the rapidly evolving world of high-performance computing. Head over to Effloow.com to get the complete 2026 vLLM production guide and start scaling your models today.